It turns out you get a similar result for the product rule of 3 functions compared to the product rule for 2 functions. The product rule for 2 functions looks like this: n prime d plus d prime n. I like to think of the functions as n and d. Oftentimes in books they're written as f and g. But the reason for using n and d is that you can use those same letters for the quotient rule. So let's say we have 3 functions: f of x, g of x, and h of x. I'm going to call those n, d, and q to keep consistent with the notation I prefer. We're essentially going to think of the first 2 functions as one piece, and then apply the product rule as we know it for 2 functions to that first piece. You could also think of that as a u substitution, with nd being u, and then q being the second function. So it's like you're doing the product rule for u and q. Essentially, you're doing the product rule for 2 functions 2 times when you do the product rule for 3 functions. One is nested within the other one.